The landscape of enterprise AI is shifting away from simple, single-prompt chat interfaces towards autonomous, multi-agent workflows. Agents within these workflows continuously invoke external tools, generate intermediate reasoning steps, and pass outputs back and forth to complete complex tasks. This recursive communication accumulates data rapidly. Every tool output, system message, and intermediate reasoning step must be retained to inform the agent's next action. This illustrates context explosion. As agents query databases, returned payloads combine with prior history, creating an exponentially growing token block. Standard models have fixed memory limits. When retained data hits that boundary, the system degrades or halts entirely. Enterprise AI cannot scale if foundational models treat continuous, massive context as an edge case rather than the default operating state. Memory is only half the equation. The other half is compute, what happens when massive, dense neural networks process these exploded contexts. This is the thinking tax, the severe latency introduced when a dense model uses all its parameters to process minor subtasks. Multiplied across thousands of daily tasks, compute costs rise and workflow timelines stretch into unmanageable lengths. On March 11th, NVIDIA introduced Nemotron 3 Super. It is an architectural response designed to directly neutralize both the context and compute bottlenecks. Solving agentic AI requires moving away from the brute force scaling of standard models in favor of highly specialized structural hybridization. Nemotron 3 Super fuses different neural network structures to leverage their distinct mathematical strengths. To absorb the context explosion, NVIDIA engineered the model with a 1 million token context window. This diagram displays a dual-path data pipeline. One path uses standard transformer layers to process discrete conceptual chunks. The parallel path utilizes Mamba layers. Mamba is a state space model architecture specifically optimized to smoothly compress and track continuous data sequences over long periods. By tracking long sequence state efficiently, the Mamba component neutralizes the memory overhead of maintaining multi-agent histories. This specific hybrid structure turns long context retention from a structural vulnerability into a stable baseline capability. Processing a 1 million token context without incurring the latency of a massive dense model requires a different approach to compute.